Tenants later on. So just write this down. Troy won a toy car that is 12.5 centimeters long with a surface area of 48 centimeters squared and a volume. No, no, no. You write this down. Yeah. And a volume of 125 centimeters cubed. I have to add something in here, sorry. Will this he knows that the volume of the actual car is 15,000. Oh, you know what? Hold on. 1 second. I'm thinking. Yeah. I'm going to make this a double whammy. A. So it's 1.5 cubic meters, okay? Watch out for that. A. Determine the scale factor used to make the toy. B. Find the length of the actual car. C. Calculate the surface area of the actual car. And I'm being criticized for being too fast, so there it is. I'm just gonna let it sit there for all that being said. All that aside, let's go through this, okay? Couple of things. I have my highlighter ready to go on demand here. The toy car is important because they talk about the toy car and then they go ahead and talk about actual. So in this case, the wording should go around actual and model, right? You can call this up there model if you'd like, right? The toy car is like a diagram, sorry. I think I talked diagram with you guys, right? Not model. Okay, scratch that. It's the same thing. Some textbooks use that. So I'm going to use diagram, right? Okay, just follow along. Okay, that would make sense that it's a bigger number than what we would like it to be. But you know, I know that some might think, oh, just fix it, right? But that's actually just a half mark deduction overall. Like let's say you do everything else right, because it's just a transfer error. That's not a concept error, okay? let's go. I will kind of make a little bit of an inventory here. If this is the actual and this is the diagram, what do I have, right? What do I have? I have the, we're talking about the length, right? The actual length, we don't know. The diagram is 12.5 centimeters. Okay. Then we're talking about the surface area. I know the surface area of the diagram, which is 48 centimeters squared. Units are very important to us. And volume, I know the volume of the toy car, which is 125 centimeters cubed. And I know the volume of the actual, which is 1.55 cubic meters. Okay? And all of that, right? I have my blank here, blank there. So if this were a table, right, this is kind of what it would look like. And this is what I'm going to focus on. Because if I have both volumes, I can find a scale factor because I need my scale factor to go from one to the other. There's no other way to do that. First thing I'm going to do is convert. It's up to you how you want to do this. I'm going to convert the cubic meters to cubic centimeters, right? I'm going to take this and convert it to centimeters cubed because the units are different. So how about we just make a note here, units, right? Okay, because it's COVID season, I would not do this on a test where I make you convert yet on top. I would just have a separate conversion question, right? But this is like two birds, one stone kind of thing. So I'm going to convert cubic meters from cubic meters to cubic centimeters. So write this down, 1.55 cubic meters times. A lot of you did this. You went 1 meter because, hey, meter cancels with meter, and you put down 100 centimeters. And then you just went, it's so easy, right? Just cancel, 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 and then you're done, right? But this is just meters, that's cubic meters. It's completely different units, guys. So what you need to do is raise this one. This is like your scale factor, and you're talking volume, right? You raise that whole thing to the power of 3. And mark my words, you're gonna see this next semester or next year, okay? So basically, we rewrite this. Let's do it one more time here. Because when you go 100 to the power of 3, right, you basically just tack 3 sets of two zeros on the back. So that's 1 million centimeters cubed and 1 meter cubed because you cubed everything in that thing. So now you're able to cancel. Only now, okay? So when you multiply this, right, you get 155, right, centimeters cubed. Okay, so this ends up being that in centimeters cubed. Okay, let me just go up a bit. So we needed to do this before we found the scale factor. So K is going to be the cube root, and I saw a lot of you do this, cube root of what? Volume of what goes on top? Volume of the diagram divided by volume of the actual. And I got to make sure I don't drop a 0, right? Same for you. Like, make sure you don't drop a 0 because it actually makes a big difference, right? And the units can just cancel out like that, which is exactly what we want. And let's find the cube root of this. Okay, so you go math 4 to start the cube root. open a bracket, you go 125 divided by 155, followed by 4 zeros, close brackets, and you get 0.0432, and that keeps going. But because this is what A is asking for, right? A is asking for scale, you just round it to 2 decimals. That's fine, 0.04, done. Okay. And the probability unit next year in grade 12, they're going to often ask you to state this as a fraction. Let's see if it works here. If you go math and just the first option, no, it can't do it. It can't do it. So that's how you would turn it into a fraction. Anyway, so that's your answer there. And we move on. So it's cube root because it's volume and volume, right? Now we can answer anything we want. B, it says find the length of the actual car. So when you're not sure, just set it up like this. K is length of diagram over length of actual. If you're not sure, just set it up like this. This is always a safe way to do this, right? And that ends up being, right, you substitute K, you know the length of the actual, which is 12.5 centimeters. Sorry, length of diagram, never mind. Sorry, folks. And that's your length of actual. When you have a decimal, it doesn't matter what course you're in, what math class you're taking, put a 1 underneath it. That's like a cheat, right? Everybody knows cheat codes, right, from video gaming, right? You go multiply and divide. So length of actual will be, and labeling everything properly is important because it's times 1 divided by this. And that's 312.5 centimeters. We are in centimeters, so there we go. And I could ask you to state that in meters. That would be just a simple dividing it by 100, right? That would just be, you wouldn't have to square or cube or do anything like that. 1 meter has 100 centimeters, right? So make sure those conversion factors that I mentioned at the beginning of the unit find their way into your study sheet. C, calculate the surface area of the actual car. Again, if you're not sure, we're talking surface area. So you know that K squared is surface area of diagram over surface area of actual. And because it's areas, I make sure that my K has a square on top, right? So it's 0.04 squared. Surface area of the diagram was 48 centimeters squared. And we're going to find the surface area of the actual. Labeling is key here. And watch what I'm going to do here. There are several ways of doing that, but I don't want you to drop decimals, right? Still do this. Put the 1 down here. Okay, you multiply and then you divide. So surface area of actual is 48 centimeters squared divided by 0.04 squared. Make sure you square it. Okay, so you get 48 divided by 0.04, and we're just going to square it and set the brackets there, and that is 30,000 centimeters squared. And voila, right? You're done. So I think the converting obviously was a bit of a learning curve, but you know, get used to that. And there's a lot of conversions in that review booklet that I gave you, okay? And so once we had the scale factor, we could use these formulas, right? to find everything else. And this question could have given you both surface areas, in which case to find the scale factor, you would have had to square root instead of cube root. And let's go even further back. I could have given you the surface area of the actual in square meters. You'd have to convert that to square centimeters. Similar steps as here, except for you would just square that conversion factor. Okay? Yeah. Well, to be mathematically correct, okay? I thought I did this in trig, cross multiplying, dividing. Didn't we talk about that? Uh, like anything like that, any proportion like that, right? You always start on the side where the variable is, get the number, travel downwards and up, and it's always cross multiply and divide. So it doesn't matter, right, where the x is, right? If the x is on this side, oh, the number is down here, you travel up, then you divide down, right? It's always cross multiply, divide. So the x can be anywhere. That's how you solve for the unknown. Obviously, there's a lot. IPR probably taught you to do this differently, right? Like, right? They would have told you cross multiply like this, right? So you'd go 3 times 20, and this would be 12x, right? Like that. And then you would divide both sides by 12, leaving you with x here, and then you go 3 times 20 divided by 12. But think about it, 3 times 20 divided by 12, right? It's the same thing. It's a pattern that repeats itself no matter what. So this is just a little different because at first you just put in k, right? You don't see a fraction there. Make it a fraction, just make it out of 1. Anything out of 1 doesn't affect, like 0.04 still stays 0.04. Okay? Oh, yes, because you're so used, yeah, because you're so, okay, hold on. This is important. You're so used to finding the new, right? What's the length of the new shape? Oh, length of new is k times length of original, correct? But in this case, they're asking you for the original. This is technically, if you want to look at it this way, this is the new, this is original. So they're asking you for original, and in that case, it's not going to be just multiplying. Got it? It's not always like it depends on what they're asking for. So if you're not sure, just set it up like this and do this, then you're always going to get it right. Then you don't have to worry about, do I multiply, do I divide, right? As long as you're consistent. Good question. That is a very common mistake. And sometimes I don't give the shortcut for that reason. Okay. Like this is the shortcut, right? The length of new is k times length of original, right? Or this is very good for a chart, for a table where you get given the original and you're trying to find the new of everything, right? This is a nice shortcut. But in this case, you got to be careful because I'm asking you for the original, not the new. The new is given technically. All right. Okay, I'm going to stop this.